Oh, you gotta start over. What was that? So where did that question from?
So this is from the worksheet from last class.
So worksheet 22?
Yeah, 24, correct.
Oh yeah, you do, okay, 24. All right. Oh, then I have it. Which question? Just
Uh, 1D.
1D. Okay. 3x to the power 4 thirds plus 5x to the power 2 thirds minus 2 equals 0. That one? Okay. Well, all you have to realize here is if you square 2 thirds, you get 4 thirds. Right? X to the power 2 thirds squared is x to the power 4 thirds. Right? Because you multiply exponents. So this is one of those quadratic types. That's where we'll make a substitution. We will say let u equal x to the 2 thirds. And when you replace x to the 2 thirds with u is just a u here. But here you'll end up with u squared. So it becomes 3u squared plus 5u minus 2 equals 0. So that's the quadratic. It's one of those hidden types. Quadratic types. Right? Now this one we should be able to factor 3u, u, probably minus 1 and a plus 2, right? You're going to get negative 2, and this is 6 minus 1. Right?
I think I got it. Well, I got 2 instead of 1. I just like started 3 times the 2 to figure 6 was the one that I needed to figure.
Right, so but you have 5, so you needed to subtract 1, so that's minus 1. Again, if you stuck on factoring, use the quadratic formula. That part is up to you. So we set each one of those to 0, 3u minus 1 equals 0. So u equals 1/3. U plus 2 equals 0. So u equals negative 2. Well, no, the answer should be in terms of x. So I need to substitute, replace u with that x to the 2 thirds again and solve for x. So we need to substitute back. So this is x to the 2 thirds equals 1/3. And this is x to the 2 thirds equals negative 2. Yeah, over here that's a u. Now what does the power 2 thirds mean? Yeah.
Cube root of x squared.
Right, cube root of x squared. Remember, the denominator is the radical, the numerator is the exponent. So really, this equation is a cube root of x squared equals 1/3. Right, so that if you look at it that way, it will be easier to solve. So first, how would you get rid of the cube root? Yeah, so cube both sides, and there's no problems cubing both sides. So if you cube both sides, this becomes x squared equals 1/27, right? Well, then how do you solve for x? Yeah. So x equals plus or minus the square root of 1/27. Right, and I definitely should, because the 27 is 9 times 3, right? So the square root of 27, this whole thing becomes plus or minus square root of 1 is 1 over 3 square roots of 3, right? If you rationalize, not rationalize, if you simplify the square root of 27, 27 is 9 times 3. The square root of 9 is 3. Is that a satisfactory answer? No, I need to rationalize that. So I'll have to, very good by the way, that you realize that there's more work that needs to be done. You need to do that. So that becomes plus or minus the square root of 3 over this 3, nothing happens to that, right? But then you also have square root of 3 times the square root of 3. What is square root of 3 times square root of 3? 3. So then it's just plus or minus square root of 3 over 9. That's what we get out of that. Okay? Well, we also have that other side. X to the 2/3 equals negative 2. Okay? But if we look at the other side and we still think of the 2/3 as the cube root of x squared equals negative 2, well, all it says that something squared equals negative 2. Well, that's not good, right? So that part has no solutions. Even if you start cubing, you're going to end up x squared equals negative 8. So x squared cannot equal negative 8. So you can just stop there. No real solutions. But this is a nasty problem. This is as bad as they get. This is really nasty. Good. Yeah, Paul definitely can help. This is nasty. First of all, you have to realize that there is a pattern. And that's not trivial just to see how, 2/3 and 4/3 relate. So that's a quadratic. So that's like half of the battle to recognize that you can make the substitution. You got that quadratic, which is, it's not too bad to factor. That's not the hardest part. Again, if you're stuck on factoring, plug in the quadratic formula, nobody cares about that part. So actually solving this quadratic is pretty straightforward. And then when you substitute back, you again kind of stuck with interpreting the power 2/3. You had to remember that 2/3 means cube root of x squared. Or cube root of x, everything squared, that doesn't matter. So, yeah, I lost track of what I was saying, but so 2/3 is another issue. But it's kind of tests you on a lot of things. Like, for example, do you still remember your fractional exponents that we learned this semester? All you have to remember, the denominator is the radical, the numerator is the exponent. So 3 is the root, 2 is the power. Okay? Oh yeah, I'm not denying that. Well, I don't know about that, but definitely complicated. Okay, good. I like that question. Let me just ask you that question on the final. That's it. That's your final. Test you on everything. Just one question. Just take it or leave it. Well, when you solve for that dummy variable, right? Because remember, somewhere here we said that u equals x to the 2/3. Right? Right there we said that. So u is x to the 2/3. So when you solve for u, you just replace u with x to the 2/3, because that's what u is. Because that's what we originally stated here. That's why I keep writing that part, so I can reference back to that line when I'm substituting back. Because u was x to the 2/3. So that's what I replace u with again. Well, because again, the fact that u is squared here is absolutely relevant, because I solved for u. U is 1/3, u is negative 2. So that's where I substitute back. If I substitute back here, then I'll come back to the original equation, so I'm just going in circles. I had to solve for u to get u equals 1/3, so I'm replacing that u with x to the 2/3. So x to the 2/3 equals 1/3. Same statement here and there. Same thing here. U equals -2. U is x to the 2/3. So here we go. Replaced u with x to the 2/3. Okay? Other questions?
Can you do
3b. Okay, well, this is just, what we have to remember is how to deal with fractions. Because if you have a problem that involves a fraction, we should definitely fix that. We don't like fractions. How do we fix? What? Multiply both sides by what? Yeah, just multiply both sides by the LCD. In this case, is 3 minus 7x. 3 minus 7x, so it cancels on that side. Right, so right away it is 4x minus 5 equals 6 minus 21x. Right? Yeah, so do some shifting. So add 5 to both sides, add 21x to both sides, so it's 25x equals 11. Right? Am I doing this right?
yeah, like how did you get 21?
I don't know.
It's yeah.
Oh, yeah, that's 14. I don't know how I got 21. I'm just getting ahead of. Oh, that's correct. No, I did my math wrong. Of course, always testing. No, that was me. So add 14x, 14x. So 18x equals 11. Is that right? Is that better?
Yeah.
Okay, so x is 11 18th.
It really is that. I just want to make sure it was that weird.
Now, there's one thing you kind of need to make sure that that your denominators don't turn into zeros. But they won't, right? I mean, if your answer was 3 7s, then it will make the denominator equal 0. So that's not good, but this one is going to work. You just have to, you don't have to check the answer precisely like we do with the square root problems. Just make sure your denominators do not turn into zeros, because that shouldn't happen. On 3D, well, that one you can just use the quadratic formula. Or do you want me to do it by completing the square, just for fun? Okay, well, again, you don't have to. This one you can just plug away into quadratic formula. Yeah. But let's say for the sake of practice, do it by completing the square. So first, get rid of the constant. Right? Then divide by the coefficient. So divide both sides by 3. We want to do that. Because we don't like having anything in front of x squared. It will make the completing the square extra difficult. So that becomes x squared plus 2/3 x. I'm going to leave a little gap equals, well, 1. Okay? So now, to add the missing term, we're going to take the number in the middle, which is 2/3. Right? We're going to half it. So divided by 2, and we're going to square that. Right? So 2/3 by 2 is 1/3. Right? So we're going to add 1/3 squared to both sides. So that's that missing piece, yes. What 3? The whatever's in front of. I want to have x squared by itself. So whatever's in front of x squared, that's what I'm going to divide by. So then the left side, by our favorite formula, is x plus 1/3 squared. That's why we added that number, so it turns into this. While the right side is 1 plus 1/9. Right? So if I do the common denominator, 1 is 9/9 plus 1/9. So it becomes 10/9. So this is my equation right now.
How do you get to the x plus 1/3 squared? Like, what happened to the 2/3?
Well, that's your formula. That's your a squared plus 2ab plus b squared. So that's this is the 2, and this is the a, and this is the 1/3 is the b. So, because that's why we added 1/3 squared, so it collapses to that. It will collapse to that every time. It's whatever this plus or minus whatever the number you add is going to go here. Well, how do I finish this? How do I solve for x now? Hmm? Yeah, take the square root. So it's x plus 1/3 equals plus or minus the square root of 10/9. Right? And the square root of 10 is square root of 10, but the square root of 9 is 3, so it's x plus 1/3 equals plus or minus the square root of 10/3. Well, man, then I don't know what to tell you. 'Cause,
I got lost.
I mean, we see. Here's the problem, guys. You guys write everything I write on the board blindly, and then you never look back at that, and you don't hear me. Listen to what I was saying here. Don't try, because you can print these notes. I mean, this is you're wasting your time by writing this down. But try to listen to what I'm saying. You know, we have certain steps in solving equations by completing the square. The first step is to get rid of the constant. That's what I did first. I added 3 to the other side. The second step is to divide both sides by the coefficient in front of the square, right? So that's the second step. So that's what we did here. We got to this part. X squared plus 2/3 x equals 1. Okay? So the third step is to add the missing piece. The way we do the missing piece, we take 2/3, whatever the number here, we half it, and we square. So that's where the 1/3 squared comes from. That's that part. So we add 1/3 squared to both sides, right? Now, the reason why we add 1/3 squared to both sides is that we end up with this expression. We want to pack all our variables inside the square, okay? And that formula that we learned on day 1 allows us to do that, go from here to here. It's a little ugly, but just because we added that perfect term, we don't even have to think about it. It's just going to always collapse to that.
Position of 1/3 x always going to fall down.
Yeah, so whatever that number squared is, because remember, it's a squared plus 2ab plus b squared. That just gives you a plus b squared, so that 2ab is irrelevant, right? It just gives me the b. Now, on the other side, I had to add the fraction, so it's 1 and 1/9. That's 10/9. So that's where we got to this point right here, right? Now, this is back to what we did originally when we were solving quadratic equations. If you have all the variables inside the square equals a constant, then you can kill that square by taking the square root. And that's where we're going good. That's where plus minus comes from, right? And then finally subtract 1/3. So it's negative 1/3 over 3. So same denominator, so x equals negative 1 plus or minus square root of 10/3. Yeah, you get the same exact thing if you use the quadratic formula. We just have to simplify it a little bit, right? But this is just for the sake of practice. So again, just you have to find a balance between listening and writing things down. Because I talk fast and I write fast. And if you try to write and listen, then it won't work. That's why I'm posting those.
You're posting those.
Well, all the notes are on the web from every class. Everything I wrote is on the web. You can print it out if you didn't write it down. For that very reason. Okay, other questions? So yeah, this is kind of on the extreme level of completing the square. Kind of hits every bit of it. So that's a good example. But yeah, of course, given options, just plug in a quadratic formula, we get the same exact answer. Sure.
Number 4.
Let me take a look.
Mm-hmm.
All right. Okay, number 4. Oh yeah, that one is all kinds of ugly. Simplify x squared over 2x squared plus 5x minus 3 plus, that's from the homework. Okay. So this is going back to first half of this semester when we had to add rational expressions. So what's the first thing we need to do when we add fractions? Right, find the LCD, but in order to find the LCD, I should factor those denominators. And this is really, you kind of have to suck it up and factor. But again, the numbers, if it starts with a prime and it ends with a prime, factoring should not be a big struggle. Because look, the only way you get 2x squared is 2x and x, right? And the only way you get 3 is 3 and 1. Now, negative 3, so one has to be positive, one has to be negative. Since 5 is positive in the middle, probably positive 3 and a negative 1 will work. Okay, because this way you get 6x minus x equals 5x. So that's how we factor the first one. The same way we should try to factor the second one. Again, 2 and a 2, so the only way we can get this, they're both going to have minuses, right? Because that's the only way to get a positive here and a negative in the middle if they're both negative. So the only way they'll work is what? Negative 1 and negative 2 there. So it's negative 4 minus 1 is negative 5. Right? So right. So we need all distinct factors, right? 2x minus 1, x plus 3, and x minus 2. So this actually allows us to do this a little faster. What is the first one missing? So we're going to end up multiplying this by x minus 2, x minus 2. And what about the second one? X plus 3, so we'll multiply that by x plus 3 over x plus 3. So when we pull everything together, is the LCD in the denominator, and in the numerator, it is x squared times x minus 2 plus x squared times x plus 3. Whatever the LCD is, I don't care at this point. No, I have to open it up, combine like terms, and do all the fun part. But that's how we combine them. So distribute x squared minus x cubed, sorry, minus 2x squared plus x cubed plus 3x squared, right? Over the LCD. Is that right? If you distribute the x squared. And combine like terms, 2x cubed plus x squared over the LCD. Is this right? Am I doing this right? Looks right. So we should always try to factor and reduce. I can pull out x squared out of the numerator, leaving me with 2x plus 1, while the denominator, well, let me write it out, is 2x minus 1, x plus 3, and x minus 2. Can I reduce anything? No. So that's it. That's as far as I can go. But the hardest part here was to do that factor. But again, when it's prime numbers all the way through, you can just, there's not too many options. You can just pick and choose. So that's what we've been doing first half of the semester. Factor, first step, pull all the distinct factors, multiply by what's missing, and then simplify the numerator. Factor, try to reduce, didn't reduce here, so we're done. On what? Did you factor the same way? See, that's the problem. You left it like this? Well, you should take it at least to this. Yeah, but so that would be totally okay. But you should still, simplify the numerator. If you didn't go from here to here, that's all right, because nothing happens. But theoretically, you should still. Okay. Yeah. Minus 8, like that. Solve. So it's n homework 10. Okay. Well, that is some sort of a quadratic equation, right? Because of the squares. But the only way we can do that, because we have that lonely x on the other side, we cannot just take square root here. We can only take, right, we can only take the square root when all the variables are inside the square and the other side is a constant. The other side is not a constant. The other side has a variable. So yes, I'm going to have to open up the square, combine like terms, and then see what I have. Okay? So first square that, so that's x squared minus 4x plus 4, right? We know how to square that. So 3x minus 8. And then if we move everything to one side, it gives me x squared minus 7x plus 12 equals 0. Right, you subtract 3x from both sides. You add 8, gives us that. Yeah? So we can factor that really easily. That's very friendly. That, what, the factoring?
Just opening it up and doing it. I was trying to add the 3 over there and then divide and do all that.
Well, but you see, if you add 3, you're just going to have, a 3 floating, but there's no way for you to get to that x. So to get to that x, because that blocks it, the order of operation tells you to square first. So that's the way to do that. So it's x minus 4, x minus 3 equals 0, right? So this gives you 4, and this gives you 3. Well, you can make that into another one of those quadratics. Because if you square root, you get x. So if we let u equal square root of x, this equation becomes u squared plus u, move 6 over, equals 0. So you can think of this as a quadratic. There are two equally simple, two equally difficult ways of solving this. So that can factor, we can factor that really easily. U plus 3, u minus 2 equals 0. So that's u plus 3 equals 0, and u minus 2 equals 0, right? So u equals negative 3, u equals 2. Well, because what is u equal to? Yeah, so that's what you substituted with. Because that's what we defined u to be. So when you want to solve back for x, you will replace that u with the square root of x. You'll replace that u with the square root of x. Because that's what you agreed to let u be. Well, this one has no solutions. Square roots do not produce negative numbers. While the other one, square both sides, x equals 4. But hang on a second. But you can do it the other way. You can solve this equation as the equation involves radical. You can subtract x, square both sides, and then you have to check that one. You will end up with two solutions. You'll end up with 4 and 9. Because if you square both sides here, you'll get 9. But then you have to check both. 9 won't work in the original. If you plug 9 back into the original equation, 9 plus 3 does not equal 6. Because remember, when you square both sides, you have to check your solutions. Because if I do this way, square root of x equals 6 minus x, right? Square both sides, x equals 36 minus 12x plus x squared. Is that right? Yes? So then move everything to one side. X squared minus 13x plus 36 equals 0. So that's x minus 9, x minus 4 equals 0. Right? So you get two solutions, x equals 4 and x equals 9. But you have to check them. So when you plug 4 back into the original, that works. 4 plus square root of 4 equals 6. So that works. But if you take 9 into the original, 9 plus square root of 9 equals 12. Does not equal 6. So that's the extraneous solution. Okay? While doing it this way, you don't get that extraneous solution, because that's where that extraneous solution really comes from. Because if you're not allowed to solve that. But if you do, then you're going to get x equals 9. That doesn't work in the original. I don't know which way is easier. Yeah, but yeah, substitution is a little, this way can totally be solved like that. So, but you have to remember to check your solutions. That's the big thing.
Well, moving forward in math, is there any preferred way that would be better?
You should, that's moving forward. You always want to solve the equations the easiest way. So that's probably easier, the second way. Right, yeah. But this technique is still very important. The way to replace a part in your statement to make it more manageable. That's what substitution is. If I go all the way back to that first question, that's a nightmare of a problem to look at. But if you make the substitution, all of a sudden it's a whole lot easier to deal with. So that idea of making a substitution, not just for solving equations, for other applications in math, instead of dealing with a nightmarish problem, you're going to dissect it into a few simpler ones. That's what we're doing. Okay? That's still a very valid technique. So you should be comfortable with both. But yeah, in this case, you probably want to do it the easier way. Which actually, I don't know which way is easier. I don't think there's any level of other questions. And what does that say? Can I just... Okay. So x to the fourth, you just have to factor. So what's the problem with that? R on homework 9? Yeah, it is very easy. What is the first, if you're asked to factor something, what is the first rule of factoring? That's exactly right. Always look for a common factor. Is there a common factor? Did I write it right?
Well, yeah, added an 11. There's no 11.
There's no 11?
No, it's just x4 plus x3.
That's what I had realized actually.
Did I write? Why did I put 11? You have 11. Which one are we doing? 1R. What can I? Oh, and then it's really written wrong here. 1R is... Oh, I see what you did. You combined R and O and somehow. 1R is x to the fourth plus x cubed plus x plus 1. While O is x to the fourth plus 11x cubed plus 30x squared. Yeah, if you put a square there, then okay. We can do both of these. So let me do O first, since we just talked about how first rule of factoring is to look for the common factor. So if you look at O, is there a common factor? Yes, what is it? X squared. So the first thing, pull x squared out. X squared plus 11x plus 30. That's the first thing that you want to do. And that was 11x cubed. Yeah, that's what that's. So now if I look at the parentheses, two numbers that multiply to 30 and add to 11. 5 and 6. So it's x squared, x plus 5, x plus 6. The way you wrote it, you would be left with x cubed plus 11x squared plus 30. That one is hard. But you were missing 1x. So that's it. That's how you factor that one. How do you factor R? You can do the grouping. That's right. 4 terms, nothing in common. Look at the first 2 terms. What can you pull out? X cubed. If you pull out x cubed, what's left? X plus 1, and oh, look at that, another x plus 1. Let me kind of put parentheses around that x plus 1, because I can't. I don't have to. Because now what am I going to pull out? X plus 1, I have x plus 1, x plus 1. If I pull x plus 1 out, what is left? Plus 1, very good. Well, every time, there's no only way to do that. 4 terms with nothing in common cannot be simplified. The only way to do that is by grouping. There's the only time when we use really grouping. You need 4 terms. Can I go further? Yeah, that's the sum of cubes form, right? So using the sum of cubes, if you refer to that, remember, a cubed plus b cubed. Again, this will still be given to you on the final. You don't need to have them memorized, but here's the formula. So a is x, b is 1, so it's x plus 1, and then x squared minus x plus 1. Right? This is the cubic. So x plus 1 can be rewritten as x plus 1 squared, and then x squared minus x plus 1. Well, no, the first part is factor, because we're trying to factor it. Now, the second part, there's nothing you can do about that. Remember, we called them, what did we call them? That was the name for those little quadratics that are produced. I think it was a degenerate quadratic or something like that. That's the name for them. They cannot be factored for it. If there was a 2 in the middle, then nice, but there's no 2, so it doesn't work.
Can I ask you about K?
Sure, what is K?
It sounds simple, x7 minus x5.
Right, so that's what's the first rule of factoring. Is that the greatest common factor? X to the fifth is the greatest common factor. And what is left if you pull x to the fifth out? Only minus 1, right? And that's the difference of squares. Right? Because when you're trying to do that common factor, you always go for the greatest common factor, which would be power 5 in this case. Yeah.
Okay, so over 9,
Mm-hmm.
x cubed plus 125, how would you...
Well, x cubed plus 125, we have to realize that 125 is nothing but 5 cubed. So that's that. So that's that formula, right? X is a and b is 5, right? So then it's just x plus 5, and then x squared minus 5x plus 25. Just using that formula. But you have to realize that you're dealing with the sum of cubes there. Good. Other questions? And what does that one say? Oh yeah, that's lovely.
You can solve, however, I tried to do the quadratic and it like...
Right, so if you do the quadratic, what made you upset all the fractions, right? Because you have to just multiply both sides by 12, get rid of the fractions. Because that's always the valid thing. Because what makes those problems hard are the fractions. Kill them. Multiply both sides by 12. See what happens. If you multiply both sides by 12, because the other side is 0, so it's still going to be 0. But if you do 12 times 1/3, what is that? 4, so it's 4x squared. 12 times x is 12x, right? And 12 times 1/4 is 3 equals 0. Now use the quadratic formula. Okay? Again, you can use the quadratic formula as it's written. It's a little nightmarish because of all the fractions. But now, should be okay. It's just negative 12 plus or minus the square root. 12 squared, what is that, 144? Minus 4 times 3 over 2 times 4, 2a. It's a lot easier if you have that instead of fractions. So no, 106 or 96? 96, I think, right? This is 48. So negative 12 plus or minus the square root of 96 over 8. Right? 96 is 16 times 6. So it's 144 minus 48, which is 96. Yeah. Right, so 96 is 16 times 6. So that becomes negative 12 plus or minus 4 square roots of 6 over 8. Right? So we can reduce everything by 4. It becomes negative 3 plus or minus the square root of 6 over 2. Right, if you divide everything by 4. You'll get the same exact answer if you suffer through fractions and then rationalize the denominator, because you'll have to do that too, I think. But that's the big message for all equations that involve fractions. Just get rid of the fractions. They're there just to mess with you. So just multiply them out. Phi LCD is 12. Clear the denominator, so it gives you something more. It's easier. I mean, I can show you how awful it is with fractions. If I plug the fractions into the... Well, actually, it's not that awful. I mean, if I do this as it's written, so it's negative b, right? Plus or minus the square root of b squared, which is 1, minus 4 times a times c over 2a, right? So that's a little ugly as it already, right? But look, you know, here you have 4. I mean, I don't want to go on. It's just awful. Because I mean, you're still going to end up 1 minus 1/3, so it's negative 1 plus or minus the square root of 2/3 over 2/3, right? Now you have to rationalize that 2/3 in the numerator. So, right? How do you rationalize that? This is negative 1 plus or minus square root of 2 over square root of 3 times the square root of 3 over square root of 3, right? To rationalize that. All over 2/3. This becomes negative 1 plus or minus the square root of 6 over 3 over 2/3. Right? This is also ugly. You want to get rid of those extra fractions. Dividing by 2/3 is same as multiplying by 3/2. Right? So 3 goes in here, becomes negative 3. 3 goes in here, becomes plus or minus the square root of 6, and 2 goes in the denominator. So we still get the same thing. It's just awful. You have to really be comfortable with your fractions. So you're better off killing them first and then just dragging.
At the top where it's negative 12, plus or minus 4, and then 6 over 8.
Mm-hmm.
How did you get rid of 12?
Well, because 12, basically, technically, I'm factoring the 4 out. Negative 3 plus or minus square root of 6 over 8. And then I'm reducing that. Or I'm just dividing everything by 4. 12 by 4 is 3, 4 by 4 is gone, 8 by 4 is 2. As long as every term is divided by 4. But this is the reason, because technically I'm factoring 4 out, and then I'm reducing that factor. Other questions? Sure. Which one? B. So the B says 3 times the absolute value of 2x plus 1 minus 5 equals 7. Well, so, but the first thing is get absolute value by itself. So you're going to add 5, right? So it's 3 times the absolute value of 2x plus 1 equals 12. Right? Then divide by 3. You want to get absolute value by itself. So it's the absolute value of 2x plus 1 equals 4. So that's the first part. You want to get absolute value by itself. But then you want to get rid of the absolute value. And getting rid of absolute value is the plus or minus part. Because if the insides equals 4, you're happy. And if the insides equal negative 4, you're still happy. So that becomes 2x plus 1 equals plus or minus 4. Which is two equations. 2x plus 1 equals 4. 2x plus 1 equals negative 4. And so we just solve them. So this is 3 halves, and the other one is negative 5 halves.
We've got, just to make sure, take plus 1, yeah, get rid of that on the left-hand side, transfer it to the right side, so you get a 5 and you take the 2.
Right. So you subtract 1, so it's negative 5, divide by 2, or subtract 1, so it's 3. So that means if you take 3 halves, you plug it in here. 3 halves times 2 is 3, 3 plus 1 is 4, absolute value of 4 is 4. And if you take negative 5 halves, negative 5 halves times 2 is negative 5, plus 1 is negative 4. Absolute value of negative 4 is still 4. So that's why we do 2 solutions.
So what while solving the absolute
Then you're done. There's no solution. You cannot do absolute value. Yeah, so the C will have no solutions. Because when you subtract 5, you get negative 3. Absolute value cannot equal negative 3, no matter how hard you try. Other questions?
Can you just do cube A one more time?
What does that say?
Um,
Now,
x cubed minus 3x squared minus 25x plus 75 equals 0.
so let's try it again. 3x cubed plus
Minus 3x squared
3x squared
minus 25x
25x plus 75
equals 0.
equals 0. So what do you think we should try to do? Factor by grouping. So if I take, is that how it's written? There's no 3 here. Okay. All right. That looks better now. Okay. So yeah, otherwise it wouldn't have worked. But factor by grouping, first 2 terms, what can you pull out? X squared. So if we take x squared out, leaves us with x minus 3. Now, again, in order for this to work, we want another x minus 3 to appear. So what do we need to take out of the next 2 terms so x minus 3 appears? Well, if I take 25 out, I'll get negative x plus 3. If I take 25 out, what should I take out? I should take negative 25 out. If I take negative 25 out, then the signs change. It becomes x, and that becomes negative 3 equals 0. Right? So x minus 3 is our common factor. We can pull that one out. X minus 3 comes out, leaves us with x squared minus 25. Right? So you can factor further, or you already start setting them to 0. Since we're already factoring, let's just break it down as far as we can go. Difference of squares on that one. So we have 3 factors. They all multiply to 0, so we can just go ahead and set each factor to 0. We'll end up with 3 different solutions, which is fine. X equals 3, x equals 5, x equals negative 5. So that's okay. 3 solutions to a cubic equation. That's very reasonable.
I have a question, but it's not a problem. I just want to know if a plus 2 over a plus 6, can that be simplified further?
Because again, like if you look at this, if you look at a plus 2 over a plus 6, right? I mean, if it can be simplified, that means the fraction can be reduced for all values of a. right? I mean, if I plug in 1 for a, I'll get what, 3 over 7? I cannot reduce 3 over 7. I mean, if I can put 0 for a, then I'll get 2 over 6. That can be reduced. But has to be reduced no matter what a is. Right? So 3 over 7 does not, so doesn't work. Remember, we only reduce through division. Now, when you're dealing with these types of problems that have fraction equal a fraction, that has fractions on both sides, there's a nice little trick that just makes the fraction go away really fast. Makes all fractions go away really fast. Well, yeah, I can multiply both sides by the LCD, which is 5 times. Well, that's what it says. Yeah, get rid of the fraction. So either do the LCD. LCD is 5 times x minus 1, 5 times x minus 1. You can do that. Or you can always cross multiply these things if it's just fractions on both sides. But anyways, the 5's cancel here, x minus 1's cancel there. So it's 5x equals 6 times x minus 1. 5x equals 6x minus 1. But it only works if it's a fraction equals a fraction. If it's a fraction plus fraction equals a fraction, then you have to do the LCD. But anyway, so the rest should be very simple. Right? So it's negative x equals negative 6, x equals 6. Right? But yeah, just keep killing those fractions. You don't want to be stuck with them for the whole problem. What else? C on worksheet 24. Well, again, how did you make the substitution? What is the value of u? Right, just like before, kill the fraction. But let's do this one from the very beginning. That's from worksheet 24. How do we make the substitution? What should we replace? Right, so we're going to say let u equal v over v plus 1. Right? Because it has that quadratic pattern. So if I make the substitution, it becomes u squared plus 2u move 8 over equals 0. Right? So it should be able to factor that one, right? U plus 4, u minus 2 equals 0. So u plus 4 equals 0. U minus 2 equals 0. Right? So solving for u gives you u equals negative 4, u equals positive 2. So now we're going to substitute back. So v over v plus 1 equals negative 4, or v over v plus 1 equals positive 2. So that's where you got to, right? Okay, well, you have a fraction. You don't want to have fraction. No, your answer should be v equals something, but how do you solve this equation? That's the easiest part. You did all the hard stuff. This is a linear equation now. I mean, so distribute 4, right? Add 4v, so it's 5v equals negative 4. So v equals negative 4/5. Same thing on the other side. Multiply by the denominator. V equals 2 times v plus 1. Distribute 2. Right? So, do whatever it takes to get v equals negative 2, I think. Yeah. Right? You subtract 2v, you get negative v equals 2. So v equals negative 2. Right?
Can you do like one from like one from like 500 or
Whatever you like me to do.
26 squared minus 12 over 54 squared.
Which one is that? Just because I have that
It's
here.
a no calculator.
Which one? 13b? Yeah, those were. We did a bunch of those on quizzes back in the day.
Yeah, and I kept like digging up
I think that's precisely from your quiz section. But what is the friendliest way of doing that?
That's how I learned. I didn't do as a kid. I did not understand them at all.
We're in that big packet 13b.
I guess I would probably a bit like being like the smallest square.
Yeah, but that's you're gonna be miserable.
Mine doesn't have that. Yeah. Mine has our 13Bs are different.
Yeah, I had mine.
No, you haven't.
Maybe I have few. Yeah, there are multiple 13s.
Uh,
There's a 13, another version of 13. Yeah, I didn't. Um, no, you don't want to be squaring 54 and subtracting whatever 16 squared and then try to reduce that. What? Well, how? Difference of squares. It's a difference of squares. It's a difference of squares. This is 26 minus 12, 26 plus 12. And this is 54 minus 16, 54 plus 16. That's the difference of squares formula, right? So that makes it 14 times 38 over 38 times 70. If you actually compute each parenthesis individually, that's what you get. You can cancel 38s right away. Yeah. Well, 7s and then the 2. So 14 goes into 70 5 times. 14 and 70. So it's 1/5. Yep. Difference of squares.
so how about the top, like A? Do you solve that the same?
Same way. You're just going to, because one of those differences is going to be 100, and it's easy to multiply by 100. While the C, 999 squared. Hmm?
We could do just kind of know like would you like add like one and then up to 1,000 and then subtract them.
Well, no. The way, but you're kind of on the right track. I'm just going to rewrite 999 as 1,000 minus 1. That's same as 999. And then I'll square that. On this, I can use my formula, right? The formula tells me go 1,000 squared minus 2 times 1,000 times 1 plus 1 squared. A squared minus 2ab plus b squared. Right? So that's 1,000,000 minus 2,000 plus 1. Right? Which is 998,001. I think that's right. I'm not sure. This is nothing really. That's right, isn't it? If I square 999, yeah. Because again, these are all simple computations. Squaring 999 is hard, but squaring 1,000 is easy. Do you remember how to do G? That one came up on one of the worksheets back in the day. That initial urge is wrong. That's the urge that I'm referring to. That urge is wrong. What? Yeah, only the whole thing squared. Here you cannot just square root. Use the difference of squares. That's the way to go. 13 squared minus 12 squared is 13 minus 12, 13 plus 12. Use the difference of squares on that. That becomes 1 times 25. Right? Which is square root of 25, which is 5. What? Because if you just cancel the squares, you'll get 1. That's not right. Right? 13 minus 12 is 1. That's not 5. I mean, you can, this numbers are pretty small. You can actually go 169 minus 144 is 25, square root of 25. But on H, you probably won't be able to do it like that. You're really going to have to go through the motions. Because those numbers are pretty, you don't want to be squaring 457 and things like that. Yeah. No, you just multiply tops and bottoms. That's how you multiply fractions. Mm-hmm. Mm-hmm. Well, that's the discriminant. That thing that tells you how many solutions. So remember the discriminant. That's the expression from the quadratic formula that's under the square root, b squared minus 4ac. So if you look at b, I mean, I'm not even going to, I mean, I don't know if I'll be able to write all that. Because remember, what happens if d is positive, then there are 2 real solutions. If d is 0, then there is 1 real solution. And if d is negative, then there is 0 real solutions. Yeah, that's when we were throwing markers and things like that. But for this equation, all I have to do is to figure out the value of d, and not really the value of d, but the sign of d. Right, it's just kind of not really finishing the problem, but so it's minus 4 times a times negative pi. That's clearly positive, right? Because square is positive and two negatives is positive. So it's something positive plus something positive. So that's positive. So two solutions. You don't need to compute it because that's a ridiculous number. Yeah, but if you can see that it's positive, because, you know, square of a negative is positive. Two negatives going to make it a positive. So it's just adding two numbers. It's still positive. So two solutions. Two real solutions. Like for, but for A, actually it's going to come out to be 0. If you can,
Very long, very next to that, or the zero. No, next to the
yeah, negative pi. But if you do it for A, it's going to come out to be 0. So one solution for A. Again, I'm not asking you to find a solution. I mean, you can go ahead and find solutions. Like, oh, I found two solutions. So therefore there are two solutions. But that's a little more work that you needed to do. Other questions?
We just do off the study guide, just rationalize the denominator.
Sure.
2 over 3 root 2.
So rationalize the denominator. So one says 2 over 3 root 2, and the other one is 5 over root 3 minus root 2. So in the first one, the only troublemaker is the square root of 2. That's what you need to fix. So you just go root 2 over root 2. By the way, is that what it's written? Oh, that's 2 over, like that, right? I wrote 3. So we'll just multiply root 2 over root 2, so that becomes 2 square roots of 2, right? And the denominator is 3 times 2. So actually the 2's cancel. So that becomes root 2 over 3. What do you do in the other one? That's right. You do the conjugate, as we call it. We're going to do the same expression, only with the opposite sign. This allows us to use the difference of squares formula, right? Because that becomes 5 times square root of 3 plus square root of 2 over square root of 3 minus square root of 2, square root of 3 plus square root of 2. So what is that? So that's square root of 3 squared minus square root of 2 squared. Difference of squares formula, which is 3 minus 2, right? Which is what? 1. So that whole denominator equals 1. So that is 5 times square root of, I don't know, I wrote it wrong. That's a 2 here. Square root of 3 plus square root of 2. Right? No, this is the answer. I mean, there's nothing else. How would you do for B in a way that I maintain my sanity, which probably is already gone, but yeah, that's actually, it should be pretty simple, but you can do something that will upset me greatly. But, so how do we simplify that? What? Well, but you're asked to subtract two fractions. Right, because the denominators are the same. Good. And now what? What do you need to do now? Yes, that's definitely not what you want to do. Right. You want to do factoring using some of the formulas, difference of squares in the denominator, and the difference of cubes in the numerator. Right? Again, the difference of cubes formula will be provided to you, as I believe it's written on the front of that packet. Yeah. So then it reduces to this, and that's as far as you can take it. That question was on your first exam, I believe. It did show up. But that urge to just cancel the squares and the cubes should be really put down. This is the bet that you already lost, by the way, after the first exam. That, oh, I lost. So A, again, this do not. So I can just combine them, right? So, because the denominators were already the same. And I can kill the 3's. And that becomes x squared plus 2 plus x. Sure you do. What is the first rule of factoring? Right. Pull out the common factor, which is x. Right? And then you can do this. So it becomes x plus 1 over 2x. You can reduce by x. That's it. How would we do 10b? The square root of 6 plus the square root of 5 quantity squared minus square root of 120. Right, and that is the urge that we need to fight. Yeah. Right, we have to use the formula. To every time you square something that contains a plus, we'll have to use this, the formula that squares things. Right? A squared plus 2ab plus b squared. How about square root of 120? Can we simplify that one? Yeah, 4 times 30. That's probably the best. So 2 square roots of 30. That's what happened to that. Is that okay? So what is square root of 6 squared? 6 plus. What is square root of 6 times square root of 5? So that becomes 2 square roots of 30. And what is square root of 5 squared? 5 minus 2 square roots of 30. Oh, how convenient, right? So what's the answer? 11. Those two cancel. 6 plus 5 is 11.
So then for the next one, C.
Right, but C is a whole lot better, right? Because what are you going to use on C? Difference of squares. So that just means take square root of 7, square that, and take square root of 5 and square that. 7 minus 5. 2. Good. And 13.1 or 13.2? With the lines? Okay. Now, remember, in order to find, this is the plan. To find equation of the line, you need two things, slope and a point, right? First version of 13C. So 13 that deals with the line. So you need to know the slope, which we usually denote by m, and you need to know any point on that line. Any point we'll denote it by x1, y1, right? And you're usually given enough information to extract the value of the slope and any point on that line. You always have that. When you get these two things, you will use the formula y minus y1 equals m times x minus x1. That's where you're going to substitute the slope and the point, and then we'll simplify to make it into y equals mx plus b. Right? That's the plan. So from the given information, you should be able to find the slope of your line and any point on that line. Okay. So now if we look at question C, they tell us that the line goes through the point 1, 7. So the point is given. Point is 1, 7. And we also know that our line is parallel to the line that passes through the points 2, 5 and negative 2, 1. Okay?
So that's actually 13B.
Oh, okay. Well, never mind. Yeah. Well, clearly I don't know how to count or... Oh, I do know how to count. It's 13A, B, C, D. I'm doing E. I'm doing E. Well, same thing. On C, what is the slope in C? So that's the point, and what is the slope? 2. Because the slope of the given line is 2, and parallel lines have the same slope. Now, in this one, we have, since I'm apparently doing E, parallel to the line passing through 2, 5, and negative 2, 1. So I can find the slope of that line. Change in y over change in x, right? 1 minus 5 over negative 2 minus 2 looks like negative 4 over negative 4 equals 1. Right? Yeah. So what is the slope of our line? 1, because they're parallel, so slope equals 1 for our line. So now I'm just going to plug everything into the formula. Y minus the y coordinate, so y minus 7 equals the slope times x minus the x coordinate, which is 1. Then I'll just simplify this. Y minus 7 equals x minus 1. Y equals x plus 6. So that will be the equation of that line. Because that's the formula, y minus the y coordinate. So y coordinate was 7, so y minus 7. Right? The formula tells me to put a minus. Yeah? Right? It says y minus y1. y1 is 7, so it's y minus 7. Same thing with the x. X equals 1, but the formula tells me x minus the x coordinate, so it's x minus 1.
I thought you were thinking like 1 would be the first coordinate, so y would be the first coordinate, y1 would be the second coordinate.
No.
You know what I mean?
No.
Y would be 2, and then the other one would be minus 2.
No, those 2 points are not related to our line. The only point on our line is 1, 7. Those 2 points are the points on that other line. So what you end up doing, you end up finding that line that we're referring to. All I just know that other line passing through those points, I don't care about that. I just got the slope out of that line. That's where I use those points. Right? Because the only point on our line that I know of is 1, 7. Other questions? Yes. Yes. Well, do you understand negative exponents? Yeah. Just flip z, not the 2 in front of z. Because when you look at, because remember the whole idea of negative exponents, a to the negative n is 1 over a to the n. That's the negative exponents are reciprocals. And then somewhere in your notes you should have a phrase that says negative exponents in the numerator end up in the denominator, and negative exponents in the denominator end up in the numerator. So when you have 1 over 2z to the negative second power, the negative second power only applied to z, not the 2, right? There are no parentheses around 2z. So that 2 doesn't go anywhere. But the only thing that makes the move is z to the negative second power. It goes on the top with the positive exponent, while 2 stays behind. Because that negative was only applied to z. And that's where the flip comes from. That's it, yeah. So all you had to do, rewrite the expression using only positive exponents. Well, if I had, let's say I had a 3 on top, it would be 3z squared. Yeah. Mm-hmm. Well, there are many ways to do 15. Okay. One way to do that, you see a negative exponent right here. That means that thing goes in the denominator. So that means it's the same thing as 3x to the negative 4th y to the 8th squared over 3x to the negative 4th y to the 8th squared. I just pushed that thing in the denominator. Well, they're identical, right? Yeah, what happens when the numerator is identically equal to the denominator? Yeah, 1. They just everything in the columns. You can multiply all the exponents. So no matter how you do this problem, it should come up to be 1. But this is kind of maybe the easiest way. You see the big negative exponent pushing the denominator, and then you see that your numerator equals denominator, so everything cancels. Answer is 1. How about 18, the very last one? Let's do this without me writing anything down. What is the answer to A? Why not? But it's a square. Oh,
I thought because I did square root 8 first, which is negative,
yes. It's 13, positive 13. Remember, when you have a square root of something squared, it comes out to be as the absolute value of something. So it's absolute value of negative 13, which is 13. Even if you use the order of operation, you have to square negative 13 first to get positive 169, I think. And the square root of that is back to 13. How about B? Fourth root of 16. 2. How about C? 5. How about D? 3. Because the cube root will come out negative 3, but there's a negative up front. Negative of negative 3 is positive 3. Right? How about E?
How, just to get a visual, how would we set that up in our mind? So that'd be 32 and then.
Well, it's 32. It's a fifth root of 32 squared. And the fifth root of 32 is 2 squared. So 4. Remember, the denominator is the root, the numerator is the power. Whichever order you like. So taking the fifth root of 32 is easier first. Fifth root of 32 is 2, right? Because 2 to the power 5 is 32. So then you're left with 2 squared. 4. Those are fun. You know, keep track of little details. Again, denominator is the root, the numerator is the power. It's all you have to remember. And it's always easier to take the root first. It's easier to take fifth root of 32 and then square rather than take 32 square that, whatever that is, and then take the fifth root of that and still end up with a 4. 2 hours? On what? Just the quadratic formula? So on 16, D, E, D or E? D. 3x squared minus 2x minus 5, this one? Okay. That's on the big. So x equals negative b, so that's 2, plus or minus the square root, b squared, that's a 4, minus 4 times a times c over 2a, right? So it becomes 2 plus or minus the square root, which looks like 4 times 3 is 12, 12 times 5 is 60, 2 negatives make it a positive, so plus 4, 64 over, oh, this is going to work out even. Yeah. So this is 2 plus or minus 8 over 6, right? No, because this you can take further. Right. So x is 2 minus 8 over 6, or x is 2 plus 8 over 6, right? So this is negative 6 over 6 equals negative 1, right? And the other one is 10 over 6 equals 5/3.
I don't know why, but in my like somewhere along the lines I started like multiplying the 8 and the 2, and then it started like rather than plus or minus it around.
Well, but it says plus or minus, right? So no
I
reason to
know, but
multiply.
I don't know what it was that I kept like when I would pull out things.
But every time your answers come out like that, pretty rational numbers, it means the original problem could be factored. But since I was just saying use the quadratic formula, use the quadratic formula. Other questions? Hmm? Well, it's only been an hour and 40 minutes. So on the final, is it going to be taking a little longer? Questions?
This one, number 6, is when you evaluate.
Yeah, that one, yeah.
Why did that?
Well, because I don't want you to be plugging in those numbers right away,
Uh-huh.
because otherwise you're going to be very unhappy, right?
And then something earlier.
Well, let me just do this. I'm going to be solving as I'm writing it. So I'm going to flip the middle fraction, and I'm going to factor it as I do it. 2x minus y, 2x plus y. Is that okay? Over 12x cubed times 2x squared over, looks like I can pull out 3x to live with 2x plus y. Is that okay? I flipped and factored. So right away, 2x minus y, 2x minus y, 2x plus y, 2x plus y. Right? Is that okay? What else can I cross out?
From on the top, so
Well, I can cross 4 and a 12. Because remember, you reduce top and a bottom. Yeah. What else can I cross out? So, but how far? Well, how many x's do I have on the top? X squared and x squared. And how many x's do I have on the bottom? X4. So they're all just going to cancel, right? And all I have left now on the top looks like just a 2. And on the bottom, it's 3 and a 3, so it looks like a 9. Right? I still have that 3 and that 3. So 2 over 9. All variables are gone. So it doesn't matter what those ugly values for x and y.
that was a trick question.
Well,
How did you get rid of the 2x squared again on the right?
Well, okay, let's just write, before I did that, so I have x squared here, nothing, nothing, 2x squared, right? So that's 2x to the power 4, if I actually multiply. Over, that's gone, that's a 3, x cubed times 3x. So that's 9x to the 4th. So then I can just cross that to 9. It's okay to rewrite those few extra steps because it gets very messy. So the point is there's no x or y to plug in, so it's 2 9. So that's why I gave you those ugly numbers, because they don't matter. Yeah. Because if I gave you something nice like 2 and 1, you can plug them in and you get the answer. Just harder to simplify in the end. But here it just doesn't matter what those numbers, what the values of the variables were. It's just 2 over 9. Everything cancels out. Other questions? Mm-hmm. And what does that say? 2x plus 1 cubed? Oh, like that. Okay. Yeah, that was a little messy. Yeah, minus 8 equals 0. Okay. The way you really want to solve that, or you'll get very messy if you do it that way. But you want to solve for x. So just like you do with the squares, add 8 to both sides. 2x plus 1 cubed equals 8. And then cube root both sides. When you do the cube root, you don't need to worry about plus or minus. So that becomes 2x plus 1 equals cube root of 8, which is 2. Right? The cube root of 8 is 2. And then just solve for x. That's a nice little linear. So x is 1/2, right? Subtract 1. 2x equals 1. So x is 1/2. Well, because that was a cube. So to cube the cube, I need to cube root it. Yeah. If this was power 5, I would use 5th root. The only difference between this and the square roots, with the odd ones, you don't need plus or minus. When I take the cube root, I don't need plus or minus. If I took the square root, I would have to throw in plus or minus. Or the 4th root or the 6th root. Even roots require plus or minus. Odd ones do not. So this one is even easier. Good? All right. I will see you on